a compile time unit testing framework. Excuse me for bad legibility or like bad font size or anything, because this was literally just cobbled together. Okay. Oh yeah. Yeah, that was a good enough introduction, right? Okay. I don't know what to say, so I'm just show you all the interface and how it works, and that's it. So to make a test in metacheck, you use this very convenient and a nice looking function. It's not even a function. You just create an alias basically, or a function, a type template, and that type template then either evaluates to a compile time true or a compile time false, like you do in metaprogramming. So it has a const for static bool value, which is either true or false, and that tells you if the test either failed or has succeeded. So in this case, repeat here is a metacheck internal function. I'm trying to make a metacheck fully self-tested. So this is one of the functions I use to test it. And basically what repeat does is takes a type and just copies it a bunch of times. So you see here, repeat is supposed to get the type, the number, and then all the values are supposed to be of the type t. So same as type t is basically all the values are t. So this is a really simple test. As you can see, it doesn't take much boilerplate or anything. And then here's the actual test case. So just a different name for the test case, and then the test wrapper with the test name, the amount of times you want to repeat the test with different parameters, and then 2 parameters or multiple parameters that says what possible inputs it could have ever. So in this case, the repeat function can have anything for the first type that it has to repeat, and any number for the amount of times it has to repeat. Yeah.
So repeat all t is the function you want to test.
Yes. That's yes.
That get generated by.
So it generates these different types, and then it does that 100 times, and then it runs the function or evaluates the template with each of those different types. Yes. Okay. Does everybody kind of understand that? It's good enough, yeah. Okay, so these are the generators. This is a really simple generator. So a generator will have a generate function that gets a seed. A seed is an internal type which has like functions to deal with it. As you can see here, increment the seed and then use that to generate a bool using it. So the gen result here is an internal type that kind of wraps it up so it's usable in next test cases, because you have to keep a running seed throughout all the test cases, and that's kind of to do that. Generators are kind of complicated, but you don't generally have to care about it, because there's a load of built-in generators, like anything or int or whatever, that just give you the value you want, so you don't really have to bother with writing your own. I recently added a nice new function, which is runtime tests. As you can see here, a type name not empty is basically the same as the other test case, where you can see it has the value, which is either true or false. And in this case, because this test doesn't have a compile time component, it is always true, so it always succeeds in the compile time. And then it has an operator, which for each of the 100 test cases, like here it specifies 100, for each of those 100 test cases with different parameters, it will then execute the operator brackets. So as you can see, this is basically MC type name here is a function that basically calls type ID and then either GCC or whatever string wrapper that gets the type name. And that's only doable in runtime, so that's why you do it here in a runtime block. Okay. And then there are test sections. This is really easy, it's just your normal test section. Make a section, give it a name, and just boost all your tests in it. Or subsections, you can just infinitely recurse sections or subsections, that's fine. Internal stuff, basically. You need a way to print your output. So I decided to make a standard gtest style printer because it works nicely in CLion. This is basically an interface to write your own. I don't care. I don't really have time to write more than the gtest, so yeah, someone do it for me. Okay, and then finally you create your printer object and just call run on all the tests, basically. So the tests do get evaluated in compile time, but you need to put this in a runtime block for all the runtime tests to actually execute. And then that will just print while running everything. And then finally, the coolest feature of metacheck. Well, first of all, here example output. So first you get the seed that was used for this this compile. The seed is per compilation based. You can either set it through a compilation flag or based on the system time macro, which is the best I can do, sadly. So yeah, you'll just get this output first. Okay, I'll compile this type, and then if it has an error, it will show that. And then the complete expansion of the generator objects, because sometimes if you write your own generators, you need that. Yeah, the coolest functionality of metacheck is minification. You might know this from other testing libraries. Basically, if a compile time test fails, then it will try to find the smallest set of parameters that will give you a non-working test result. So, for instance, here I broke the repeat function to only work when it doesn't. It has to repeat 0 times. So in this case, it says, okay, the smallest failing function is with any type and 1 repetition. So that way it's really easy to find where your problem is in a template type. That's sadly not possible for runtime tests because the entire minification process is compile time, so yeah. And yeah, that's everything. That's easy.